Welcome to this explainer. Imagine, just for a second, that you're swimming in a massive, chaotic ocean of raw, unfiltered numbers, letters, and symbols. Sounds kind of overwhelming, right? Well, today, we are doing some digital alchemy. We're going to explore exactly how we take all that chaotic raw input and transform it into incredibly valuable, highly organized digital gold.
Let me ask you something to really kick things off here. What would you say is the most valuable resource on Earth right now? You might immediately think, oh, it's gold, or maybe oil. But look around at this incredible digital age we're living in. The real answer? It's data. Absolutely, it's data.
Okay, let's dive right into this because we really need to clear up a massive misconception. People use the words data and information interchangeably all the time, but they're absolutely not the same thing. Look at data. Data is just raw, unorganized measurements. Things like the number 1.5 or 67 kilograms. On their own, they literally mean nothing. But information? That's what happens when you give that raw data some context. Suddenly, 67 kilograms becomes the average class weight is 61 kilograms. Boom, now you have something meaningful that you can actually evaluate and use.
So how do we get from point A to point B? The transformation from meaningless data to valuable information happens through one crucial middle step, and that is processing. This processing step is basically the engine. It takes those raw, isolated facts, manipulates them, and churns out the output we desperately need: clear, organized information.
Section 1. The Blueprint of Order. Building the Universe.
You know, before a computer can actually process anything, that raw data has to be categorized. It's a compounding scale, and it scales up exponentially. A computer doesn't just look at a massive, complex database right off the bat. Actually, it starts incredibly small, building upwards through a really strict logical hierarchy to create the stunning, organized systems we interact with every single day.
Here's the exact anatomy of how that digital storage works. It starts at the very bottom with a character. That's just a single letter or number, the absolute smallest unit of data. Group those characters together and you get a field. Think of a field like a column on a form for a person's first name. Combine related fields and you build a record. That's an entire row representing all the info for one specific subject. Take a collection of those records and you've got a file, like a whole table of employees. Finally, when you integrate multiple linked files together, you reach the ultimate structure, the database.
Section 2. The Processing Engine. Making sense of the chaos.
Now that our data is beautifully organized, it's time to fire up that processing engine. Notice how we can take basic inputs and create immediate value through processing. Here, we've got a set of raw test scores for Anshu, Ratasha, and Ravneel. By manipulating the data, in this case just doing a simple calculation to add up the different subject marks, we output a final, actionable total marks column. It's foundational, sure, but it's a highly powerful example of information processing in action.
But wait, we don't have to stop at just combining data. We can sort it sequentially, like putting it into alphabetical order, or we can summarize it. Take a look at how this data has been summarized by position. Just by organizing the information, we've instantly turned a flat list of test scores into a competitive ranking system. And as you can see, Ravneel clearly takes the #1 spot. Traditionally, all of this processing happens in two very different ways. On one hand, we have batch processing. Picture a cinematic montage where files just pile up over time, hours, days, or even weeks, and then boom, they get processed all at once. A perfect example of this is your monthly credit card statement or a bank passbook being updated at the end of the day. Contrast that with real-time processing, which happens instantly. When you pull cash out of an ATM, your account is updated right then and there. Instant action, entirely made possible by direct access storage. Section 3. Enter the database, the ultimate digital custodian. So, to manage all of this fast-paced, high-stakes information, we really need a database management system, or DBMS for short. Now, a database itself is just the collection of stored files, but the DBMS, that is the active software acting as your ultimate digital custodian. And what makes this software so incredibly powerful? Well, it tirelessly handles 5 core functions. It creates records by structuring the data, it updates records by letting new data be entered seamlessly, it maintains records by correcting any errors, it provides structured access to users, and, absolutely crucially, it controls the entire integrity and security of the system, preventing massive catastrophic errors.
To pull off all these precise functions, a DBMS relies heavily on something called a key field.
A key field uniquely identifies one specific record in a massive sea of data. Think about airline reservations, right? A passenger's name isn't a good key field. I mean, there could easily be two John Smiths on the same plane. The flight number alone isn't enough either, because that flight flies every single day. But if you combine the passenger's name, the flight number, and the specific date, now you have a unique key field that prevents disastrous booking mix-ups.
Under the hood, this amazing software relies on three main components. First up, the data dictionary, which strictly defines the properties of every single field. Then, the query language. This is brilliant because it literally lets you ask the database direct questions. Using a language like SQL, you use simple English-like commands like select or join to pull out exactly what you want. And finally, report generation, which formats all those answers into stunning, easy-to-read presentations for the folks making the decisions.
The advantages of adopting a database management system are absolutely game-changing for an organization. You get seamless information sharing across departments. You gain ironclad security, where only authorized users get in. And because the data is centralized, you have way fewer files and significantly reduced data redundancy. But the crowning jewel? Data integrity. When a record is instantly updated in one place, it updates everywhere. That completely prevents those serious, expensive conflicts between different departments operating on old information.
But hold on. Let's flip the script for a second here. Building this flawless digital fortress does not come cheap. And honestly, it isn't easy. Databases have massive disadvantages too. We're talking heavily increased costs for sophisticated hardware and software. There's immense management complexity. Maintaining currency requires endless training for personnel. You often get locked into vendor dependence, and you're forced to endure frequent, very expensive upgrade cycles just to keep your systems running smoothly.
Section 4. Securing the vault. Protecting the treasure.
So you spend an absolute fortune, you've trained your staff, and you've built your ultimate digital fortress. But what happens when someone actively tries to break in? Is your data truly safe? Databases are basically treasure chests holding incredibly sensitive personal information, your confidential medical records, your private credit history. If unauthorized intruders gain access to this data, it can be terribly misused for things like hiring decisions or making promotional choices without your consent. The stakes literally couldn't be higher.
So the crucial point here is that we aren't just protecting against nosy employees. We are actively defending against malicious attacks. Computer viruses are hidden instructions that migrate through networks, embed themselves deep into databases, and do active intentional harm. There have been numerous cases where these viruses have been launched into systems, causing completely unrepairable damage to an organization's most valuable asset.
Because the threat is so real and the data is so incredibly valuable, security has to go way beyond digital firewalls. To protect these massive hardware vaults, organizations require serious physical measures. We're talking physical guards posted in computer rooms, rigorous ID checks, and automatic biometric fingerprint scanners. Especially when data travels across wide area networks, protecting both the physical and digital borders is an absolute necessity.
We've seen an incredible journey today in this explainer. From a chaotic ocean of raw inputs to the highly secure, beautifully managed databases that basically run our modern world. But as we wrap up, it leaves us with one lingering thought. If data processing transforms chaotic numbers into the very blueprint of our lives, who really holds the keys to your digital identity? Something to think about. Thanks for joining me, and keep learning.